So this is going to be a review day, or just a practice kind of day. So you're just going to go work all the problems however you want to, write the answers down on the worksheet or on another piece of paper, do them whatever order you want to. You can go do all the easy ones first, and then go back and do hard ones, or do them in order, or just go do the hard ones first, and then go back and do the easy ones, whatever you prefer, okay? But do check your answers when you're done against the videos. I'll have one video for the first page front and back, and a video for the second page front and back. Okay, so whenever you get ready to work number one, hopefully you notice there's no variables in here. So literally this is just math. Just put this in the calculator. 3 squared times 2 raised to the -3. So you use that little rooftop key. Just hit enter. It's going to give you a decimal answer. So put each of these fractions in the calculator and see which one matches your decimal answer, right? And if it doesn't match any of these, then of course it's not here, but it was C. Here we go. The ones are not numbered on this front page. So up here we're simplifying. I put it bigger so we could see it. Those were kind of small down here. Now you may wonder, how come we can't do like we did on some of the polynomials, put y equals in front of this and just type it in and put y equals in front of the answers and find one that matches it? That is a very good question. You would if I had already used two variables. When I put my y equals over here, I'm creating a new letter over here that's y. And here's the x's, but then I need another something for these y's, and I don't have another letter to use. So you cannot do that. So instead, you just need to simplify these by hand because I already had two letters going. So we have parentheses, and of course that's going to use all of these exponent rules are going to be on that reference sheet. So when you have the power rule, the parentheses with an exponent outside it, you multiply. 1/2 times 4 is x squared. So this is now x squared. And then I still have y 1/2 times y 1/2. And of course, if you're multiplying, you add. So 1/2 and 1/2 is 1. And since they're different variables, I can't multiply them together. And they're both positive, so I'm done at that point. So there it is, h. So as long as you don't have any negative exponents and you only have one x piece and one y piece, and you've simplified the coefficients as far as you can, you're done. All right, again, we're simplifying this thing. So again, take it in stages. Do the coefficients first, the 3/6, and just see what answers match that. Eliminate answers as you go. So that's 1/2, which means A is out. Okay, everything else has a 1/2, 1/2, 1/2. So everything else has a 1/2. So pick one letter. You can either do the A's, you can do the B's. C doesn't help because they all have the same C answer. And if I look at the B's, I'm looking B, B, B. Well, there's a B3 and a B3. So I'm thinking let's not do B's, I would do the A's. Just because they all have a different A answer. Sometimes you have to do 2 letters, but do 1 letter at a time. Just ignore everything else but just the A's and write them down just like they are. So this is a division problem, so subtract. That means I have a squared left over, and the leftovers are going to be on bottom because there were more a's on bottom to start with. So there should be an a squared on bottom. Which one has an a squared on bottom? There it is, D. Don't need to do any others. So again, equivalent, and you may say, can I do y equals? Well, if I do y there, then there's an x, and I still have more y's over here, and I don't have another letter for that. So can't do it. All right, so if you wanted to, there's no really coefficients, they're just ones, and so nothing is going to change with that. And you could just do the y's only, and though it's only a y5, right? And that's it. So there's going to be a y5 on top. But they all have y5 on top, so other than this one. So let's get rid of this one. That one doesn't look anything. And I would not leave anything with parentheses, so that's not simplified. All right, so now what we're going to do is get rid of negative exponents by moving them to the bottom. So this is now x4, y5. Those are both positive. They stay where they are over x to the 6th. Now I only have one y piece, so it's going to stay where it is because all the answers say that. And then x's on top and bottom, that's division, so subtract. 6 minus 4 is 2, and the leftovers are going to be on bottom because that's where the more, make that a y, where more x's were to start with. There were more x's on bottom, so that's where the leftovers are going to be. So y5 over x squared. Which one matches that? It's that first one right there. Okay, what expression is equivalent to this one? So again, we're simplifying. It is multiplication. There's nothing between them. There's no exponents outside the parentheses to do the power rule, so this is just plain multiplication. Multiply the big numbers, the 3 and the 4, and then add your exponents. So 3 times 4 is 12. So it is not that number, and it's not that number, but it is a 12, and it is a 12. If we multiply the x's, x3 times x squared, add them, so that's x to the 5th. There's x to the 6th. I don't want that one. There's x to the 5th. So I'm pretty sure it's that one, and there's just a single y, nothing else. Which expression is equal to this? So again, we're simplifying, and again, I got too many variables over here to just put y equals in front of it. Start with the coefficients only. Ignore all the variables and just put 15/6 in the calculator. When you put 15/6 in the calculator, that reduces down to 5/2. So it is not this answer. It's not this answer. I've got 2 possibilities with 5/2. Pick one letter. These have negatives. That's x to the 5th. I think it's a 5. Yeah, pretty sure. Yeah, it's x to the 5. I say that. I'm looking closely. Yeah, I think it's 5. And then y squared over y. So I'm kind of thinking the y's are all positive, so I'm thinking, oh, let's do that. So if you just write down the y's, that's y squared over a single y, right, to the first power. So subtract, because it's a division problem. 2 minus 1 is 1. That means I have a y left over on top. And that's where I want a single y on top. Do I have a single y on top? No, they put them on bottom. Is there a y on top? Yes. Now, you could have done the x's or you could have done the w's if you wanted to, but I kind of like the y's because they look simple and easy. Okay, this is an interesting one. 4, 3, and this bottom one down here. So these 3 bottom word problems, these are challenge problems. So if you don't want to do these at all, y'all don't have to do them. You can skip them. But if for those of you that are shooting for a perfect score or just want to challenge yourself, give those a whirl. This one we still need to do, though, because it's just plain old do the coefficients first to simplifying this thing. So 9 over 3 in the calculator is the whole number 3. Oh, I'm sorry, that's 9 over 36. Sorry. Make sure you pay attention. 9 over 36. So when you put 9 over 36 in the calculator, it reduces down to 1/4. So that answer is out. 1 over 6 is out. There's 1 over 4, and this one is also 1 over 4. So I have 2 answers that have 1/4. Pick again one letter. And I'm looking at the c's right now because I think c squared over c squared, right? So if you want to pull it out here where you can see it, c squared divided by c squared. It's a division problem. What do? You subtract, which gives you c to the 0. And what's anything to the 0 power? It's 1. So these basically canceled out to a 1. So this is like times 1 out here. So c's just went away, right? They just canceled out. And that has c's in the answer. And there are no c's in this one. So I'm thinking it's that one. And you would be right. Okay. The total cost to produce this number of widgets is this amount of money. What expression represents the cost of a single widget? So this is kind of like saying I spent $12 and I bought 3 burgers. What's the price of 1 burger? How would you figure that out? You would take the total cost and divide it by the amount of burgers, right? Total cost divided by the number of ones. So that gives you $4 is what each burger costs, right? So it's following that same thing. You're going to take the total money and divide it by how many items you bought. So this becomes 16x3 y squared over 2xy3. I think that's y3. Yeah, it looks like a 3. Yeah. There we go. And then we can simplify that. So if you just do the coefficients, only 16 over 2 is 8. So there's an 8, there's an 8, there's an 8, but this one is now gone. Pick one letter to do. If you want to do the x's, this is x3 over a single x. So if you want to rewrite that, you can, but 3 minus 1 is 2, and the leftovers are on top, so I have an x squared on top. There's an x squared on top. That one does not have an x squared on top. Both of these have x squareds on top, so I'm going to get rid of that one. And if you do the y's, you got y2 over y3. When you subtract them, I have a single y on bottom. Which one has a single y on bottom? It is that one. There we go. Given the area of the circle, A is the area of the circle, can be determined using, this is the formula for area of a circle, A equals pi r squared. What is the radius of a circle with an area of this? So this is what I'm trying to get as the answer, right? So what you're going to do is take this piece here, pi r squared, and we're going to drop in different radiuses because they say we're looking for the radius. So all of these answers are radiuses, and the r's, we're going to plug them in for the r. So this is pi, and where the r is, I make parentheses, and it's going to be squared, right? So one at a time, you can drop in each of these radiuses, square it, and see if you get this as the area. And notice pi is still in here, okay? So we want to know if this side will simplify down to this. So I'm going to put this first one in. Actually, no, we put a bunch of them. I'll put this one in first. I should have done this in pencil. 4A10, B6, okay? Now remember when you've got powers, you multiply. So this is 6, 2 times 6 is 12, so this is B12. Do I have B12? I do not have B12, so that's not the answer. So we're going to try a different one. Let's try H. This is going to be 4A6B4. See, if I had done pencil, it would have been better. I could have just erased that. So this is inside, so I'm going to multiply 2 times 4 and get B to the 8th. Do I have B to the 8th? We do. 2 times 6 means I have A to the 12th. Do I have A to the 12th? I do. And then this is a little 1 here, next to the 4. So this is 2 times 1, so that's 4 squared is the very beginning. So I'm going to write it up here where you can see it. 4 squared, a to the 12th, b to the 8th. I just multiplied 2 times 4, 2 times 6, 2 times 1 because you multiplied the exponents. 4 squared is what number? Put in the calculator. It is 16. Is this my less? Yes, and I still have the pi sitting over here, right? So they just kind of put the coefficient in front of everything. Pi is almost like a variable. It's just sitting there. And then you have a 12, b 8. So that one does match. Again, these are your challenge ones, okay? Just to stretch to see that. I don't even know that they would even put those like that on the STAAR test, but you know, hey, you never know. A circle has a radius, so this is the radius. The area of the circle can be found using this formula. Notice they give you these formulas when they're fancy formulas. So this radius is going to go in for the r. That's what r represents. So area is equal to, and they want you to find the area. So we're looking for the answer. Area is equal to pi times my radius squared. And the radius they said to drop in was 3x cubed y8. So we multiply the outside exponents times the inside one, and 3 has a 1, so this is going to be 3 squared, x to the 6th, and y to the 16th. And we still have a pi sitting here. And then 3 squared is 9, and so we always pull the coefficient out front, so this is going to be 9 pi x to the 6th, y to the 16th. So I'm looking for that answer. 9 pi, so it's the 9, not a 6. Get rid of the 6's. And x6, y16. x6, y16, there it is right there. Aren't those fun? Okay, so there's that side. The back of this front page, so those were all the exponent ones. Following those exponent rules. Back to our normal old review stuff. Which of the following quadratic equations is equivalent to? Okay, so if we're equivalent, are they going to make the same graph? Yes. And it's already in y equals, so I can go graph it, put each one of these in, and see which one goes right on top of the original graph. So those are easy peasy ones in the calculator. You literally just put them in, graph them, hit tab to put in another equation and graph it, and looking for the one that goes right on top of it. And of course, F does that. What is the solution to the system? Where do we go to solve two equations? We go to LinSolve. So add, subtract screen, menu 3-2, type in the two equations, hit enter, and you will have the intersection, right? And there it is. This one is, here's an exponential function, and they want to know what is the domain. Remember, domain are my x numbers. So these numbers here, all right? Is it going to go left forever? Yes. Is it going to go slightly right forever? So I will eventually use all these. So I want all the x numbers. There it is right there. Had they asked for range, by the way, it never reaches 0 because it never touches it. So I want all the y numbers greater than, because it's going to go up forever, all the y numbers bigger than 0, but it will not be or equal to. It's just greater than. Okay, what is the range of this function? So it's in y equals, so just go graph it. Look at the picture. And when you go graph it, I think it was, what was that, 3? I don't remember. Yeah, so the x-axis was down here somewhere. And the parabola did this thing. And so it was, the very bottom of the parabola was at the number 3 on the y-axis, right? So, and it goes up forever. So I want all the y numbers bigger than 3. So all the y numbers bigger than 3 or equal to, because it is touching right there, solid. Which of the linear equations below is equivalent to this? If they're equivalent, will they make the exact same picture? They will. However, are these in y equals format down here? No, they're not. Bummer. So you could go graph this one, and you can look at it, but you're looking for one of these that makes the exact same graph. So you're just going to have to solve each of these for y equals. I know, that's kind of a bummer. So you just wind up solving each one of them. So I'm going to do this one because there's room down here, right? So to get y by itself, I subtract 5x on both sides. Minus 5x minus 5x. And then those are gone. This is 3y is equal to, and then I have negative 5x plus 6. I'll rewrite them side by side. Divide by 3, divide by 3, divide by 3. And then when I simplify these fractions, y is equal to, this stays negative 5/3 x. And 6 divided by 3 is plus 2. Oh, look, are they identical? They are. So once you've solved them for y, it should look like one of these, and you won't even have to graph them to check. But there's no way to do these other than just solve each one for y. They're not in y equals format, so you've got to solve for y. So solving for y is a good skill to still be able to do on the STAAR test. Not part of your easy 30, but definitely doable. You guys are good at solving for y. Which graph represents the solution of this inequality? Okay, so we just want to graph this inequality. That's all we're doing is just graphing it. Because y equals is already on one side by itself. So this is shade down because the y's are on the small pointed end. So I'm going to shade down below the line. Is it a solid line or dashed line? Yep, it's a dashed line. So this one's gone. That one I keep. This one's gone. And that one I keep. I got 2 dashed lines. Now, since it's in y-equals format, this is the slope number -3. So is the slope negative? Yes, so it's going to be going down. So that one's going down. This one's going up. So it can't be this one because that one has a positive slope. And this one is shaded below, which makes sense. So there it is, G. So shade up, shade down, dashed line, solid line. Those are the easy things to pick out. And when it's in y-equals format already, you can just pick out the slope and the y-intercept, make sure they match. A cashier put all the quarters and dimes received during a shift into an automated money counter. The counter said that there were 180 total coins worth $22.50. How many quarters were there? This is one of those systems of equations, but they didn't ask you to write the equations. They just want to know how many quarters there were. But you have to go through the whole process to find that. You've got to write the 2 equations and then go put the 2 equations in LinSolve and then go pick out which number out of that ordered pair is the right one. So, if you remember when we did these back in the day, I'm going to make quarters be my x's and dimes my y's. It did not matter which one you did as long as you make a note of which is which. Then, let's see, quarters are worth how much? 0.25. So I'm going to have 0.25x and dimes are worth 0.10. All right? So this is the money equation. If I take my quarter money and add to it my dime money, it should equal 22.50. So 0.25x plus 0.10y is equal to 22.50, right? There's one equation. How many coins were there? 180. So here's my other total. Whoops, that's not a very pretend. Let's just get rid of that. 180. So the next one equals 180. If I take my number of quarters, add to it my number of dimes, x plus y equals 180. Here's my 2 equations. I go put them in LinSolve and go see where they intersect. And they intersect at 30, 150. So the question is, which one of these numbers is the number of quarters and which one is the number of dimes? What did I make the quarters be? I made the quarters the x's, so I want the x number in this, which is the 30. 150 is the number of dimes. So 30 is the right answer, and notice they put the other number as an option in case you didn't know what you were doing. All right, again, these are some of the harder questions on the STAR test, okay? These are the ones that will get you an A. Which point for a line passes, which equation for a line passes through this point and has a slope of 0? Now, we could just go put all these equations in the calculator, except you can't do x equals. So those are out of the question, but you could put the y's and look to see if they have a slope of 0 and if they go through that point. But slope of 0, is that my horizontal or vertical? If you're not sure, can you write Hoy or Vux? Let's write both of those. Here's Hoy, H-O-Y. Here is Vux, V-U-X, right? The slope is 0. This one has a slope of undefined because it has a U in it. This one has the O. This is my slope of 0, right? So this is the one I want. It is a horizontal line. What does the equation start with? It starts with y equals a number. So see these y equals ones? It's one of those. What is my y number? It's a 4. Which one is it? It's y equals 4. There's the answer. Okay, go to the next video to check your answers on the last page.